Hello and welcome! Recently I bought many graphics cards, which I need to test and possibly repair since they all have been sold as non-functional. The cards in this stack are from different generations, from more modern PCI Express back to PCI, like this Matrox Mystique. I have no clue if some of those are just working or if there is some repair work to be done. In the pile there are also AGP cards like this ATI Rage Fury or the famous 3DFX Voodoo 3. Okay, let's unpack all the cards and take a brief look. Here they are. The most interesting one from collectors' points of view is of course the 3DFX Voodoo 3. Those cards got very hot and needed at least a good heatsink, even better an additional fan. I got this card without any cooling parts and I hope this card hasn't been used like that, otherwise the chance that the chip survived is pretty low. On the chip I can see a scratch. This could come from removing the heatsink, which was usually glued on this card. One memory chip seems to be damaged. It has a scratch on top and one corner seems to be chipped off. Well, most likely this card is dead indeed. The next one is the ATI Rage Fury, also known under the name Rage 128 Pro. This is actually a nice card which unfortunately was released too late back in the days. This card delivered competitive results to NVIDIA Riva TNT and 3DFX Voodoo 3, was even outperforming those cards in 32-bit color depth. However, it was released almost a year too late, shortly before Riva TNT 2 was already hitting the market. And so this card never got the attention which it deserved. However, it made the foundation for the upcoming and very successful ATI Radeon series, which lives on until today under AMD brand. Back then, however, AMD didn't yet bought ATI and the next graphics card was a powerhouse delivering outstanding performance and cutting-edge DirectX 8 support. After 3DFX was bought by NVIDIA, this was probably the first graphics card which showed NVIDIA that there is another serious competition incoming. As I said, the Rage 128 Pro was already a clear sign of successful engineering in the house ATI, and there was a Radeon 7000 series in between, which was still a bit too late. But the ATI Radeon 8500 was a very good card, outperforming easily NVIDIA's GeForce 3 and even competitive against the very successful GeForce 4 Ti. The successor of this card, the Radeon 9500 and 9700 cards, eventually taught NVIDIA to fear, but that's a story for another day. And today we have this Radeon 8500, which I would be very glad to have in the collection. The next card is a lot less interesting. It seems to be some cheap PCI Express card which I will throw away. Just kidding, nothing is thrown away here, what can be repaired. This seems to be a GeForce 8400 GS card with 256 MB DDR2 memory. Well, actually it is quite boring indeed, but as a test card for some PCI Express boards, it will be good enough. Looks like some capacitors are bulged and need to be replaced. Otherwise the card looks really clean. The next one is also quite boring and very common card. As I said, ATI was trying to close the gap back then and the 3D Rage Pro Turbo came too late on the market, losing against the competition. However, it was good enough for mid and low-range office PCs as well as servers. That's why this card was probably the most common one back then, which was a nice move from ATI because even if they couldn't take over the high-end market, they earned a lot of money with this model needed so much for the development of their flagships later. By the way, the chip 3D Rage Pro Turbo was re-released later using more modern manufacturing process under the name Rage XL. And that chip was used in the servers for another 15 years or so. Today you even still can buy PCI cards with that chip, which is pretty awesome for a graphics chip which is more than 25 years old. The next card is again an AGP one, and this seems to be an NVIDIA GeForce MX 440 SE, a DirectX 7 card, which is feasible alternative for the much more expensive GeForce 2 Ti. This card has obviously some mechanical damage and at least one capacitor seems to be ripped off. This card definitely needs some soldering work before we can try it. Just like the next card. This one seems also to have a ripped off capacitor. This card is probably a NVIDIA GeForce 2MX, but I'm not completely sure. The next card is an AGP version of a River TNT-2. The inscription says TNT-2MA, and this is most likely a TNT-2M64 with memory bus cut down to 64-bit. Also a very common card which was used in low-end PCs. However, for a SuperSocket 7 system, this card is a perfect candidate, since there the CPU will be the bottleneck and not the memory on the graphics card. The card looks good, but I see a decoupling capacitor missing near the memory chip. Most probably the card would run also without that, but in case the card is working, I will add a missing capacitor. And the last AGP card on the table today is an ATI Radeon VE. As I previously mentioned, after the Rage 128 Pro, ATI started the new line of cards under the name Radeon. The first cards were released under the name Radeon 7200, which were quite good, but 1 year later ATI released for the low-end PC market the Radeon 7000 with only 64-bit memory interface. The cards were still good enough for the office PCs and some gaming, but they were not competitive to the GeForce 4MX, for example, and also they were completely uninteresting for the games market. The Radeon 7000 was also released as Radeon VE, and this is what we have here. Not a super interesting exemplar. Yeah, on the back there seem to be some missing capacitors. Once again, a missing capacitor is often not a reason for not working hardware, but if there are multiple of those, that could be critical, so I'll have to populate those. Well, and last but not least, the two PCI cards. First, the more interesting one, the Matrox Mystique. Those are purely 2D cards. Well, Matrox could do kind of 3D, but that's not worth the time. However, Matrox cards were good 2D cards with outstanding video signal quality, a nice complement to a 3DFX Voodoo cards for a Socket 5 system. Unfortunately, this card seems to went through some gold scrapers. Someone obviously tried to remove the gold-plated pins, but did it in a more gentle way than usually. The feature connector was half desoldered and not just cut out as so often. At least it looks like the card can visually be restored to original state. I'm curious if it's still working. The Tseng AT4000 is not quite as interesting, and this card also has visible damage. Here is a scratch and a couple of pins could be squeezed together. I'd say we need a microscope here, but let's check the cards first if they show any signs of life. In my last video I finally built a testing rig for hardware from the 90s and the early 2000s. The timing was not a coincidence. I had to test this pile of graphics cards and also a lot more hardware from my to-do box. The system is nice for in-depth testing, including Windows, benchmarks, you name it. But the whole PC doesn't fit very well on my workbench, so for brief tests, just to see if a graphics card is alive at all, this open board will do. As you see, it has AGP1 and PCI slots, so it is possible to check most of the cards using it. Let's start with the PCI cards. The Tseng Labs AT4000 is the first. Nope, this one seems to be dead. There's some kind of video signal though. It's clearly visible that there is different color above this line. And also I can see kind of pixel lines or something like that. This could be anything from broken RAM DAC to broken video chip. But anyway, the card is non-functional and I'd have to take a deeper look into it later. The next one is the PCI Matrox Mystique. Nice, we have a video signal. I didn't expect that, to be honest, taking into account how the card looks like. Once again, it is ridiculous that scrap hunters destroy expensive retro hardware, which sometimes costs tens or even hundreds of dollars, just to get metals out of it worth a couple of cents. Not very smart if you ask me. Okay, the next one is this GeForce 2MX, as I believe. This is a universal AGP card, which should work in AGP 1 mainboard 2. This card has a missing capacitor, but it should at least power on without that. Even the fan is spinning. It is slightly scratchy though, but it works. And we also have a video signal. Yep, GeForce 2MX as expected. And we have a post screen, so the card is alive to some extent. Okay, I checked all the cards which could have been tested without the need to be fixed. First of all, the bad news. The most interesting card, ATI Radeon 8500 and the 3DFX Voodoo 3 are of course faulty. The good news, they are not completely dead. Both cards generate video signal, but the image is broken. The Radeon 8500 shows such vertical stripes. The 3DFX Voodoo slightly less obvious stripes, but the text mode looks funny, where every second letter is red. I believe the memory on these cards is defective and needs to be replaced. Unfortunately, I seem not to have any new memory chips which would fit, so I'll have to find some donor cards in my scrap or order new chips on the internet. This means that I'll come back to these cards in one of my next videos. Since both cards already show errors during the post procedure, I didn't even try to do any further tests, so let's talk about the rest. First is one of the least interesting cards in my opinion, the ATI 3D Rage Pro Turbo. This card just worked out of the box. The card has only 4 MB of video RAM, so the resolution in 3D games and benchmarks is limited. I could select 800 by 600 in 3D Mark 99 and it even started, but the scene was messed up. In 640 by 480, however, everything worked as good as it could on this card, which is not a powerhouse as I mentioned, and so the frame rates were pretty slow. The rest of the cards need some rework before further testing. Well, the Zank ET4000 seems to be dead. I took a brief look under the microscope at the scratch near the graphics chip and it turned out that multiple pins were shorted indeed. I reflowed the solder, cleaned the area around and checked for continuity, but unfortunately the card is still dead and currently I'm still not sure what is wrong with it. Maybe it deserves a separate video. However, luckily the Matrox Mystique seems to work as you previously saw. By the way, this is even a Mystique 220, which has improved RAM DAC and 4 MB of video memory instead of 2. This means that the card supports higher resolutions and color depth. However, as I said, this card was probably a victim of gold hunters, which left some scars. Let's see if the original state can be restored. There are 2 pin headers, one was almost removed. This one is almost fine, only one bent pin and one pin has to be soldered back in place. The pin seems to be pushed through. I didn't have new golden plated pins in my stash and it would be fine to use silver color pins, but I wanted to restore the look of this card, so I decided to go a step further and disordered a gold plated pin header from scrap. The problem with used pin headers is that the plastic slightly melts when the pins get soldered and desoldered, so the pins slip through and are loose. It is then kind of hard to perfectly align those when soldering. The repair shouldn't look like a crap. That's why when soldering such headers I use a cut-off plug from an IDE cable. When you push the pins into it, they will be aligned all at the same height. Looks almost as good as new. Time to test the card on the Windows 98. The card is still working and is also detected by this system. As I previously said, this is a nice 2D graphics card with VGA 2.0 support out of the box. A perfect candidate for late SVGA DOS games and early Windows 95 as a sidekick to the 3DFX Voodoo accelerator. The Matrox Mystique itself has barely 3D features worth talking about, so the test on the Windows is limited to the driver installation, which worked without any issues, and switching the resolution to a higher value at 32 bits to get the most video memory involved. I couldn't see any glitches. Also in DOS, the card was reported as 4MB VGA 2.0 version and did work without any issues, so I guess this was a nice catch. The next one is this GeForce 2MX. It has a ripped off capacitor and unfortunately the pad was ripped off. I could try to restore the pad, but there are a couple of unused places for capacitors which are probably in parallel. Yes, this and these pads for capacitors are in parallel, so I could just solder a new capacitor to the remaining places. Also, these solder pads are in parallel. Those caps are probably used for voltage stabilization on the memory modules. The distance of the capacitor to the consumer is kind of important and the caps should be set as close as possible. However, in this case, I don't think this is critical. The ripped off capacitor was in the middle. I think I'll solder two new caps, one on each side of the memory chips, then the distance to each chip is somewhat similar. Here's the old pad, where the capacitor used to be. The capacitors on the other memory chips are 10 microfarads, 16 volts SMD ports. I don't have any at hand, but I have through-hole capacitors with similar specs in my stash. Just have to bend the pins to the side and solder the caps as they would have been SMD parts. Okay, the capacitors are all in place. Let's clean the fan and replace the thermal paste. And the card is ready for tests. It's working fine. The video quality is not great, but that's not the fault of the card. I use a VGA to HDMI converter, which often delivers quite poor image quality. Anyway, the card itself holds up nicely and delivers the expected performance. Unfortunately, GeForce 2 was just a DirectX 7 card, so the capabilities were limited. But for later DirectX 8 games, this card was too slow anyway. Well, even there it delivered somewhat playable frame rates and was a common choice for a student pocket back then. I think this card was the most used one of its time. I had a similar one back then too. How about you? And back to the other budget cards of the 90s, the TNT2 M64. As you probably remember, this one had a ripped-off capacitor. Probably nothing what would be absolutely necessary, and I don't know the exact value of the required capacitor. It is used to filter out high frequencies, voltage ripple, to stabilize the power on the memory chips. I added one with 22 nanofarads, which should be fine. And of course, after so many years, the thermal paste should be replaced too. In Windows 98, the card was detected properly and I had zero issues with the drivers. I didn't overclock it and left everything at defaults. All 3D tests ran successfully through and without any glitches, so the card works. But it was struggling a lot with the performance. Especially in higher resolutions, the frame rates went down like a stone. The cut down video memory bandwidth resulted definitely in a big performance drop. This card is a nice option for a SuperSocket 7 system where the CPU would limit the playable resolution to, let's say, 800 by 600 anyway. For a Pentium 3, like the one I tested the card on, the TNT2 M64 is a terrible bottleneck. But the good news is that the card is totally working. The next card is the GeForce 4MX 440 SE. This one I didn't test yet because it also has a ripped-off capacitor which hangs on the rest of the trays. First, it could short something. Second, it's near the memory voltage regulator and is probably more important for the stability than the others. The bad news is that also here the pads have been ripped off the PCB. But the good news is that the PCB design allows through-hole capacitors as an option and the holes still look good. Let's remove the old capacitor first. The copper plane was partially ripped off the PCB together with the capacitor. This is not critical, I could just cut it off, but let's just glue the rest of it back in place. The crack in the copper can be soldered together. To glue the copper, I'll use some super glue. There will be no drag on it later, so it's more a cosmetic thing, so the copper doesn't stand off. I will also put some solder mask around the edge to fix the area. Looks good enough. Here I have a through-hole capacitor which should replace the old one. We are almost there. However, I somehow overlooked that there is another capacitor missing, which also needs to be replaced. So, the second capacitor is soldered. Now it's time to replace the thermal paste and do some tests. Off camera, I already cleaned and oiled the fan. It slides very well. Hopefully it is still intact. And it is. The driver reports the card as normal MX440 and not as MX440 SE. But maybe this is normal. All 3D benchmarks worked also without any problems. I tested this card with 3D Mark 99, 3D Mark 2001 and Quake 2. The results were actually quite impressive, and I compared those to some results of my tests from the past. I tested another GeForce MX440 SE a while ago and the numbers were quite a lot lower. So I dug that card out to rerun some tests again. This is that other card which I tested before. For me there was always the MX440 and the MX440 SE, where the SE was the slower version. I always thought that clock is the only difference. Now I have two MX440 SE cards which deliver significantly different results. So what's the difference between these cards? Well, first of all, I couldn't find reliable information about MX440 SE cards. Different sources report inconsistent specs. Some sources say that the cards were made based on the different chips, NV17 and NV18. Others report that it was based only on one of those. I tried to find out which cards I have, and both are based on the NV17 chip. At least this was reported by CPU-Z. Also, both chips are clocked at 250 MHz, so that's the same, and the difference is only memory related. Before I thought that the MX440 SE are all cards with 64 bits memory interface, where MX440 has a 128-bit one. But it turned out that there were 64 and 128 bits of MX440 SE variants. And this is what the difference between those two cards. This one has a 64-bit memory interface, and this one has a 128-bit memory interface. Wikipedia, as well as some other sources, report that there were MX440 SE cards with DDR and SDR memory. DDR stands for double data rated and means that the effective clock of the RAM is doubled. For example, the memory on this card runs with 200 MHz, so the effective clock is 400 MHz. A clock which is never achievable by SDR memory, which usually runs at 166 or 183 MHz at best. This card runs at 333 MHz, so the clock is slightly lower than on this card. Probably the higher clock here was used to reduce the performance impact of halved memory interface width. Ugly marketing tricks. Both cards were sold as MX440 SE, but they were by far not the same. And the higher memory clock didn't help either. Furthermore, if we take a look at the datasheet of the chips which are used on this card, we will see that the used 4 nanoseconds chips are actually rated to run at 250 MHz or 500 MHz effective clock. This means that this card should be actually also a great overclocker. But let's stick to the default clocks today and take a look at some examples. The 128-bit card delivers in Quake 2 at 1024 by 768 around 214 FPS, where the 64-bit variant renders only with 162 FPS. I'm not going to do a full-scale benchmark today, but the difference is visible through all the tests. For example, 3D Mark 99 with the 128-bit card scores with 8,986 marks, where the 64-bit card makes only 8,650. Here the difference is not quite as high, since I ran the benchmark with the default 800 by 600 resolution, and the negative impact of a narrow memory interface grows in relation with higher resolutions. Probably at 640 by 480 the difference in performance wouldn't be quite as high, but at 1280 by 1024 the 128-bit variant completely destroys the 64-bit version. What is the takeaway from this story? Such a GeForce 4 MX440 SE can be quite a fast and affordable performer for a retro system from around the year 2001. But when you find such a card to buy, make sure you get one with 128-bit memory interface. These two cards are both officially called GeForce MX440 SE, and though they are very different. And here are all the cards once again, which I was able to fix and test today. At least these are now all working. I decided not to show all the details, cleaning, drivers installation and testing, since it wasn't too exciting and mostly just worked. The GeForce 8400 GS got new capacitors and finished all the tests just fine, but it is also slow PCI Express card without any secrets to discover. Well, I wouldn't say that any of these cards are hot tip. Neither would I say that any of those are complete crap. It depends on the generation of a retro PC you would like to build. Like PCI Matrox Mystique, which is only a 2D card with just 4 MB of video RAM, but it is a perfect card on a Pentium MMX with a 3DFX Voodoo. The ATI 3D Rage Pro is also a good card for an early Pentium 2 system, if you don't care about time-authentic hardware but want a cheap retro Pentium 2 or Super Socket 7 system with this ATI Radeon VE is also a good choice. It costs next to nothing and is fast enough to not end up as a bottleneck in such system. By the way, this card also works fine. I soldered the missing capacitors and the card finished all the tests without any problems. Yes, it was quite slow compared to, let's say, GeForce MX440 SE, but the image quality was good. The card has a DVI port, so I could capture the video signal without a digital to analog VGA converter. And again, an early Pentium 2 also would be a huge bottleneck for a GeForce 4MX440 SE, where such a Radeon VE would be probably a good fit. For a Super Socket 7 system like an AMD K6-2, the Riva TNT-2 is a good fit. Even though it's just an M64 version of the card, it should be still fast enough and even more or less time-correct option. As you see, even simple and affordable cards by today's retro expectations can be very interesting. It doesn't need to be the fastest graphics card if your CPU would hold back the system anyway. The fastest card among the repaired stack today is this GeForce 4MX440 SE, which actually surprised me. I wasn't aware that SE cards existed in so many different versions. From the performance point of view, this 128-bit card was quite a good fit for the 1.2 GHz Pentium 3 system where I tested it. The image quality was also good. I had no issues with drivers. With the new capacitors, the card was totally stable. All in all, no complaints whatsoever. Even the fan is still intact and is actually even silent. Unfortunately, I was not able to repair all of the cards today. There was not only the PCI Tseng ET4000 card, but also very interesting ATI Radeon 8500, and of course the famous 3DFX Voodoo 3. As I said, I'll have to search my scrap if I can find some memory chips there which I could salvage or order new ones online. The memory chips for the 3DFX are easier to get. They were quite common. But the ATI Radeon 8500 uses DDR memory with very low latency of 3.6 nanoseconds, which seems to be a challenge. Also, I'm still curious what's wrong with the Tseng ET4000, but all that is a topic for another video, and I hope you enjoyed being with me today. As always, thank you for watching, and goodbye.